Good morning, and in case you don't watch this presentation in the morning, good afternoon, good evening, and good night. My name is Huang Xin, a PhD student from Software Institute, Nanjing University. You can see my team members in the first slide. Thanks to them for giving me this chance to introduce our work to you. In general, our work is about the future. In the future, all companies will be software companies. Agree or not, software has become an important part of our life. People need software in nearly all the aspects of their life. So as the industry, maybe the software engineer will be one of the most common jobs in the future. So, how can we get so many software engineers? To me, the answer is education. Software engineering education. This is the motivation of our work. In order to realize the current state of the art of the software engineering education, reviewing the existing studies is a good beginning. Do you have some ideas on how many studies on software engineering education have been published? According to our work, over 1,700 primary studies have been published till 2019. It is really a hard work to review so many primary studies. As a result, we adopt systematic literature review to get information. Systematic literature review is an empirical method to get information based on the existing primary studies. Through systematic review, we can get the overview of the existing primary studies easier. Our work is a systematic literature review of systematic literature review, or you can remember this as a tertiary study. This is our research questions. We want to know the overview of the existing studies in systematic literature review, and what issues they have addressed and haven't addressed. Following the guidelines of performing systematic literature review, both automated and manual search were applied in our research. In the automatic search, 5 most well-known databases were selected in our search, and 9 manual venues for search were selected based on our experience. After applying the selection criteria, 26 papers were included for further synthesis. This is the distribution of the studies over year, as is shown in the figure. In the recent years, relatively more studies were published, and in the following presentation, I will introduce the results of our work briefly. This is our proposed landscape, the basic part of our research. We use 2 dimensions to locate the included papers so that the readers can find the papers they are interested in quickly. First, the vertical axis represents the content to be improved, and the horizontal axis represents the methods and tools which can help improving teaching. For instance, when we come to this paper, Wall 17, you can see that this paper is aimed at improving testing, and the mentioned methods and tools in this paper is simulation and game. So you can find content on how to use simulation and game in testing in this paper. Besides the 2 dimensions adopted in our landscape, there is also another structure for describing the results of our work. Maybe you still remember our research questions. In addition to the overview, we want to know what issues have been addressed and haven't been addressed as well. To answer the 2 questions, we use the three phases to structure them. First, in the design phases, we noticed that approaches to addressing two issues are proposed: the design learning outcomes and obtain teaching material. Bloom's taxonomy provides some levels for industry to design their learning outcomes, and some empirical methods, such as systematic lecture view, can help you find suitable teaching material rather than the only experience. Some of you may know that the ACM IEEE Software Engineering Curriculum's guidelines. It recommends the practice which should be taught. However, only 2/3 of the practice are taught in the courses, so something may be wrong now. Next, in the delivery phase, through many methods have been proposed to deliver knowledge. Which ones are relatively more effective is still a question. The included papers tell us simulation and game and using open source projects were confirmed useful. When it comes to a global software project, communication skills and handling task allocation are the two most useful skills. On another hand, the evaluation of some methods and tools may need more attention. We find different conclusions based on the same method, the pair programming. I guess that too many factors can affect the results. And in the assessment phase, we can find that it is feasible to choose appropriate assessment tools, automatic tools, manual tools. A large number of assessment tools has been developed. The instructors can choose the feasible tools according to the requirements. However, at the same time, automatic and manual tools have their own weaknesses. So, how to achieve a balance between different criteria are still to be addressed. In addition to the issues in the included papers, there are also some challenges we want to discuss with you. If you review our included papers just like me, you will find that the research objects of these studies are mainly targeted at the students who don't have a high level of skills. The undergraduates. So, what about the other students? You cannot teach a master student just like teaching an undergraduate. Students with different levels of skills can have different learning objectives. The proposed method, the Bloom's taxonomy, cannot work well when it comes to the master students. Even when it comes to the undergraduates, there are also some difference between students. And it is reported that the students' interest can have a greater influence on the learning outcomes. We can find many studies mentioned that the factor in their report. For example, pair programming games can increase the students' interest. However, how to evaluate the results? We did not find any systematic approach to follow in the courses, even when the instructors want to put some gamification elements in the courses. So, how to increase students' interest in the courses may still need some more research to deal with. What are the most important factors in teaching? Different people may have different answers here, but I think the interest may be one of the factors. With the guidance of the instructors, the adopted teaching methods and tools can be more useful and under control. As you know, the time and effort spent by the instructors are limited. We adopted teaching approaches and tools such as peer programming, games, assessment tools. One of the goals is to reduce the teaching cost. Maybe this is the reason why simulation game is the most popular topic in systematic literature review. But there is still much work to the instructor to do. It is necessary to achieve a balance between teaching cost and learning outcomes. Okay, the above is my report about our research. Due to the time limit, I did not introduce many details. If you are interested in our research, you can find more information in our paper and protocol. Thank you for listening.